Hey guys, here we are for lesson number 9, applying area of circles. So, we are on page 69, so if you want to open up your book. 9.1, the area of this field is about 500,000 square meters. What is the field's area to the nearest square meter? Assume that the side lengths of the square are exactly 800. So we did this problem the other day in class, but remember, we'll go over it again. Now remember, the area of a circle is pi times radius times radius. So we need to figure out what this radius is. Okay? Well, we know that each side of the square is 800. So if we draw the diameter in here, it's also the width of the square. So that's also 800. That means my radius is going to be 400. So in my calculator, I'm just going to go pi times 400 times 400. So pulling out my calculator, I have pi times 400 times 400, and I get 502,654.82. Well, it says to the nearest square meter. So here's my meter, so we look at the number next to it. It's 0.8. So 4.8 is closer to 5 than it is to 4. So it would be 502,655. So if we look down here, there it is. Letter C, 502,655. Okay? Remember, pi times radius times radius. So 9.2, page 70, it says, each square has a side length of 12 units. Compare the areas of the shaded regions in the 3 figures. Which figure has the largest shaded region? Explain your short reasoning. So each side is 12. So 12 there. So that means my radius here is 6. So to find the area of a square, we go 12 times 12, which is 144. So the whole thing is 144. Now, for the circle, the radius is 6. So we go 6 times pi, and we get 113.09. So 113.09. We subtract the 2, right? 144 minus 113.09, and I get 30.91. So all I did there is I found the area of the square, base times height. 12 times 12 is 144. And then I found the area of the circle, pi times radius times radius. So 36, 6 times 6 is 36, and 36 times pi is 113.09. And then I just subtracted them. So if I look at B, I'm going to do the same thing, except for now there's 4 circles instead of 1. So my area is still 144. 12 times 12 is still 144. Okay? But now, if I look here, let's draw this. I have 2 diameters, so this diameter is 6 and this diameter is 6. That means the radius is 3. So 3 times 3 times pi. So radius times pi. So if we go 3 times pi, I get 28.27. But then I have 4 circles, so I'm going to times that by 4. And I get 113.09 again. Ooh, look at that. 113.09. And so I get 30.91. So any guesses on what letter C is going to be? 144 for the whole square, right? Now we have 3 squares. So 12 divided by 3 is 4. So this one's 4, this one's 4, and this one's 4. So that means the radius is half of that, which is 2. So 2 times 2 times pi, 2 times 2 times pi is 12.56. So one circle is 12.56, but we have 9 of them. So we're going to times that by 9, and look at that, we get 113.09. And we end up with 30.91 again. So even though they have different circles, different amount of circles, the shaded region is still the same. Okay. Now if we look here at number 2, it says each square in figure D has a side length of 1. Compare the area of the two figures. Which figure has the more area? How much more? Do you explain or show your reasoning? Well, let's break things up. Here's 1 square. Here's 2 squares. Okay? Here's 1 half a circle, 2 half a circle, 3 half a circle, 4 half a circle. So we have 2 squares, and we have 4 half a circles, or 2 full circles. So we have 2 squares and 2 circles. So let's look at E. Well, E, here's a square, here's a square, here's a square, here's a square. So now we have 4 squares here, and 4.5 circles here. And let's see, we have a quarter of a circle, quarter of a circle, quarter of a circle, quarter of a circle, quarter, quarter. So we have 1, 2, 3, 4, 5, 6 quarter of a circle, which would give me, there's 1 quarter, 2 quarter, 3 quarter, 4 quarter. So 1 whole and 1 half circles. So now we need to find the area. Well, each side length here is 1. So 1 by 1 here. So 1 times 1 is 1. 1 times 1 is 1. So we have 2 for the square, and then my radius is also 1. So pi times radius, well, pi times 1 is pi, or 3.14, and we have 2 of them. So we're going to go pi times 2, we get 6.28. So 2 for the squares, 6.28 for the circles. So we did 1 times pi, and we got 3.14, and then we times that by 2 circles. Okay? So we get a total of 8.28. 8.28 is my total. Okay, looking at the next one, I have 4 squares, and each one has an area of 1. 1 times 1 is 1, so 1, 2, 3, 4. So 4 for the square, and then I have 1.5 circles. So once again, my radius is 1, so 1 times pi is pi, or 3.14. And then I times that by 1.5 circles, and I get 4.71. So 1 times pi is 3.14 times 1.5 circles is 4.71. So 4 plus 4.71 is 8.71. So which one has the larger area? This one, by 0.43. How much more? 0.43. We just go 8.71 minus 8.28, and we get 0.43. Okay? So there's that one. Running the track revisited. The field inside the running track is made up of a rectangle and 84.39 meters long and 73 meters wide, together with a half full circle at each end. The running lanes are 9.76 wide all the way around. What is the area of the running track that goes around the field? Show, explain your reasoning. So I need to find the area of the orange part. Okay? Let's just find the area of the green part. So the green part is a rectangle in the middle, and then 2 half circles, which is a full circle. So the area of the rectangle, remember, is just base times height. So to find the area here, I'm just going to go 84.39, 84.39, and I'm going to times that by 73. So 84.39 times 73 is 6,160.47. Okay, so that's the rectangle in the middle. Now we need to find the area of the green, or the circles here. So this half circle and this half circle. Well, 73 is my diameter, so to find my radius, I'm going to divide 73 by 2. So 73 divided by 2 is 36.5. So then I just go pi times radius, so pi times 36.5 times 36.5. Okay, so pi times 36.5 times 36.5 is 4,185.39 if I round. Okay, so now I'm just going to add those together. 6160.47 plus 4185.39. I get 10,345.86. Okay, that's how you find the area of the green part. Now, if you wanted to, you could still take 6.1. Nope, just kidding. Now it's going to be bigger. So to find the area of the whole thing, you find the area of the rectangle in the middle. So it's still 84.39 wide, but then you go to 73 plus 9.76 plus 9.76. Multiply that together and you get the middle, and then do the circles as well, and then you subtract the two. Okay? We're just going to go ahead and skip to the end. Whoa. Look at that. Part of my thing is not moving. Fancy. Well, let's just go ahead and notice that. All right, lesson 9 summary. The relationship between A, the area of a circle, and R, its radius, is A equals pi times radius squared, or pi times radius times radius. We can use this to find the area of a circle if we know the radius. For example, if a circle has a radius of 10, then the area is pi times 10 squared, or 100 pi centimeters squared. We can also use this formula to find the radius of the circle if we know the area. For example, if a circle has an area of 49 pi meters squared, then its radius is 7 and its diameter is 14. Sometimes, instead of leaving pi in expressions for the area, a numerical approximation could be helpful. For the examples above, the circle with the radius 10 has an area about 314 centimeters squared. Pi times 10 times 10 is going to be 314. In a similar way, a circle with an area of 154 has a radius about 7 times 7 times pi. We can also figure out the area of a fraction of a circle. For example, the figure shows a circle divided into 3 pieces, so we can go pi times radius divided by 3, or multiplied by 1/3. The book likes to multiply fractions. I think dividing by whole numbers is better. Remember, on your assignment today, we have a circle with a 12-inch diameter that's folded in half and then folded in half again. What's the area of the resulting shape? So I have a circle that's folded in half once, and then it's folded in half again. So I end up with this part of the circle. I want to know the area. Well, I know my diameter is 12, so my radius would be 6. And think in your minds, how much of a circle is that? So then you're going to find the area of the circle and divide that by how many sections we broke it up into. Okay, and then number 2 is the face of a clock has a circumference of 63. What is the area of the face of the clock? Well, if they give us the circumference, I need to find the radius. So to get from circumference to diameter, we divide by pi. And then to get from diameter to radius, we divide by 2. So then you just go pi times radius times radius. Okay, remember you can always email me if you have any questions.